All right, for our next example, we're going to use page 6 from the notes, number 2. And again, first I'm going to use the sides, and then I'm going to look at the diagonals. This is an either or kind of thing. You can use the properties of the sides or the properties of the diagonals to prove whether your shape is a parallelogram, a rhombus, a rectangle, or a square. So if we use the side lengths, if we find the length of each side, since these sides are horizontal and vertical, I don't have to use the distance formula. I can just use subtraction, which means the sides are a good way to go for this proof. So just using subtraction, I see that from Q to P is 6, same for from S to R, and to go from S to Q or R to P is 12. So the opposite sides are congruent, but not all the sides. That means it's a parallelogram because the opposite sides are congruent, but it's not a rhombus because a rhombus would have all of the sides congruent. All right, so we know it's a parallelogram, not a rhombus. Then when we look at the slopes, that's when we can test whether or not it's a rectangle. If we get the slopes of a horizontal line, like QP or SR, that's just a slope of 0. It's horizontal. SQ or RP, again, we don't have to actually calculate anything for the slope here. This is basically an infinite slope. It's going up a total of 12, and it's going over 0. When you divide by 0, you get an error. These are vertical lines. 2 vertical lines are always parallel. 2 horizontal lines are always parallel. So the opposite sides are parallel. And the consecutive sides, like SQ and QP, those are perpendicular because a vertical line segment and a horizontal line segment will always be perpendicular. So because the opposite sides are parallel, it's a parallelogram. And because the consecutive sides are perpendicular, it's a rectangle. It is both a parallelogram and a rectangle, but rectangle is a more specific name. A rectangle is a type of parallelogram. So the most specific thing we can say about this shape is that it is a rectangle. All right, we could have done the same thing using diagonals. So exact same shape. This time we'd want to first check to make sure it's a parallelogram by seeing whether the diagonals bisect each other. So we do that by finding the midpoint of each diagonal. Again, to find the midpoint, you take the 2 x values and add them together, divide by 2. Take the 2 y values, add them together, divide by 2. So the midpoint of QR we find to be -1, -1. If I do the same thing for SP, I again find -1, -1. Since they intersect at the same point, and that point is the midpoint of each of them, they bisect each other, and so it's a parallelogram. Next, we can look at the slopes. If the diagonals are perpendicular, then it's a rhombus. If I look at the slopes of these, QR has a slope, it goes down 12 and over 6, so it's a slope of -12 over 6, which is -2 over 1. For every 1 it goes over, it goes down 2. SP, on the other hand, goes up 12 and over 6, which reduces to a positive 2 over 1. These are not perpendicular. They're opposite, but they're not reciprocals. In order for this to be a reciprocal, we'd have to have, like, for instance, -2 over 1 and positive 1 over 2. This would have to flip. It's not flipping. They're not perpendicular. It's not a rhombus. We can also use the length of the diagonals. Here we do have to use the distance formula, which suggests that the sides, since we didn't have to use the distance formula, this was a better way to go, an easier way to go. But this is perfectly viable. We can find the length of each of these. They are going either up or down 12 and over 6. In both cases, that comes out to a square root of 180. These are the same, so the diagonals are congruent, and we have a rectangle. So I can say that PQRS is a rectangle.